Hello everybody and welcome back to the Code Wrinkles channel for a brand new video. And I really hope you're doing well and you're ready for this very, I hope, interesting content that we'll deliver today, because this is the very first time on this channel that we'll tackle the idea of design patterns. And we'll get started, of course, by trying to implement and explain the most simple of the design patterns that we might have, and this is the Singleton pattern. Now, before we get started, just a few words about what I intend to do in a series of videos about design patterns. So design patterns are really useful because they provide us with common solutions to common challenges that we might have in our day-to-day coding life. And it's actually very good for us as programmers not to reinvent the wheel every time we need to implement something or every time that we face some challenges, because I'm sure there might be other developers before us that have faced the exact same challenges. So that's the whole concept of having design patterns. But I want to really try to understand them and why we should use them, when we should use them. And that's why I will try in all these videos to come up forward with some meaningful examples or scenarios in which we try to implement a certain design pattern to solve a certain problem that we might have there. And for this very first video, as said, we will talk about the Singleton design pattern, and we'll try to implement a very, very basic load balancer in a console application, because I think that this concept of load balancer is very easy to grasp for all developers, and we can easily explain why we would need to implement a singleton, or why we would need to implement the load balancer as a singleton class in order to be able to count, for instance, requests and to know exactly where we want to route requests to which servers and things like that. So let's get started and let's jump right into code. Here is a very simple console application. And by the way, I have created the GitHub repositories in which I will put all the projects that we will use while creating these videos for design patterns. So I will provide the GitHub repository link in the description below. You might want to check it out. And each time we create a new video on a certain design pattern, we'll simply add a new project to this solution containing also the name of the design pattern that we try to showcase. And in this case, we have, for instance, this CWK design patterns singleton project, which is the very first one, because this is the very first video in this whole series, I hope, about design patterns. So in this project, we'll get right into it and we'll try to add a new class here. And I will call this, where is this class? I will call this load balancer, because what we try to do here is to model a load balancer. And let's also make this class public, at least for now. Good. Now, once again, when we think about this load balancer, what is the purpose of a load balancer? Where it is an instance of something, let's say, that gets some requests, could be of different type of requests, and it is able to route those requests to different servers that might handle, or that would be able to handle, those specific requests. Now, the whole idea is that in order to be able to send a request to a certain server, the load balancer does actually need to know to which servers actually it did send the previous requests, because load balancers have different type of algorithms that they use in order to send requests. It could be a round robin, where the first request gets sent to the first server, the second request gets sent to the second server, the third request gets sent to the third server, the fourth request gets sent once again to the first server, and things like that. But it could have also other algorithms that it could decide based on a load that a certain server has, or based on the health of the server, and things very similar to that. Of course, we will not be able to implement all these type of algorithms here, because this is not the purpose of this video, but I guess we get a very good idea about why we need to do that. So we need, in this case, a load balancer, and we need to make sure that it is a singleton, because we would have to keep track about to which server we send each request. And also, for instance, if we want to provide the analytics to consumers, for instance, how many requests did we send? How many requests were maybe sent to a certain server, and things like that. So in this case, of course, that we would need to keep track about everything that was sent to all the servers in order to be able to service this type of requirements. Now, when we think about implementing a singleton class, actually that is very, very easy. And from my point of view, the whole skeleton about this is first that we would need here a private static load balancer instance. So we will have a field of type load balancer that right now doesn't have any instance assigned to it. But the whole concept of this singleton is that we will have a private constructor, so the consumers won't be able actually to create a new instance using the constructor. So in this case, it would be public load balancer, and that should be it. And in this load balancer, well, right now we actually don't do anything, but what we could do here is we can implement here a public, this time, static load balancer method. So it returns a load balancer, get load balancer. Now, and here, actually that's the whole point of, or the core idea of this singleton, or the implementation of a singleton class, is that we provide a static method, something like a factory method, but about factories we will talk in a separate video because that is a totally different design pattern that we will tackle. So right now we have this static method getLoadBalancer that returns a load balancer. And here actually what we have to do is something very simple. So we just need to do an if check. So if, not like that. So if instance equals null, so if we don't have any instance, then we say instance equals new load balancer. So in this case, we are able to call the private constructor, and then we simply return instance, and that's it. You can imagine that basically after we create the load balancer for the first time, each time that a new request comes in, or each time that this method gets invoked, we won't enter actually in this if statement, so we will just return the same instance that we have previously created. And voila, that's actually it. That's all the concept about a singleton design pattern, at least the core concept of having a singleton design pattern. Now, let me go here in the console, and here this console class, this program class, we can consider this to be the consumer of our load balancer. So what we can do here is we can have here a var b1 equals, this was a classing, this was a static class, a load balancer, and we have here get load balancer, and we have here var b2 equals, once again, load balancer, get load balancer, and let's have also a var b3, which would be a load balancer, get load balancer. Now we can do a very easy check, or very simple check, to see if those are really equal, because as this is a class, when we check for equality, it will actually by default check for reference equality. So if they have the same reference to the same memory location, then we will consider them, or CSharp or .NET will consider them as the same instance. So we can say if b1 equals b2 and b2 equals b3, then we just console.writeLine. It's a very simple thing here, same instance. So that should be it. Let's get rid of this console write line with hello world, because we don't really need it anymore. We don't care about it. So let's run this application and see what we get here. And we see that we actually got the same instance. Now let me go here once again, and let's go here and put a breakpoint, or better than, let's put a breakpoint right on the if. So let's run the application. So we get here for the first time, in this case instance equals null. So of course we will go here into this one, and that would be it, and then we will return the instance. Now if we go on continue, we see that instance this time is not null. So in this case, we just return the instance, and then once again, instance is not null, so we just return the instance. So every time we actually return the exact same instance of the load balancer. So that is actually very, very cool. Now let us also go into the more specific implementation. And here, what I would like to do is I would like to have a private list of string. Let's keep a list of string that would represent our servers. And let's create the list. Now in this constructor, we can add some servers. Add. Let's have here server 1. And let's just paste this several times. Let's have 5 servers. We'll just change here the number. This would be server 2. This would be server 3. This would be server 4. And this would be server 5. Now, let's also have here a private int request count. And we can set this to 0 right when we create a new instance. Okay, and then what we can do here is, for instance, let's get rid of this breakpoint. So what we can do here, we can implement this public, it would be a void method, and we'll call send request. And this method would actually very simply take a string, in our case for the console application, that represents a request, and we'll actually use the random class to generate some random numbers in the range of the list that we have here. So what we'll do here is we will create var rnd equals new random. Okay, and then what we could do actually here is we can, but right now I see that this console is still opened. So what we can do here, we can generate actually a next, and we say that var r from a random number equals rnd.next, and we provide here the server's count that will define the range in which we will get a new number generated, a new random number, servers.count. And that should be actually it. Now, what we can do here is we can just go here, console write line, and we'll use some string interpolation here. So for each request, just 1 second. Yeah, we'll say here something like request. And in this case, we provide the request as a string, sent to, and here servers dot, sorry, not dot, because we want to get the server by index r in this case. And yeah, that should be mostly it in this case. Okay, good. So this is the send request. So what we can do here, for instance, is we can go back here to the consumers, and let's create a new one, balancer equals LoadBalancer dot get LoadBalancer. And what we can do here is we can, for instance, create a for loop, and we start from, let's start from 1 here, and we go until, let's try to send 20 requests. And here what we will do is we will simply send the following request. Let's we should use the balancer dot send request. This is exactly what we want to send. However, what we want to send here is only the number of the request, and in this case, let's do it like that. Also, we'll use string interpolation. We request, and it will be request and the number here. So in this case, we would have something like that. Good. So if we go here and run this application right now, we should see the following thing: that the request 1 was sent to server 4, request 2 was sent to server 2, and so on and so forth. So we see that basically that works perfectly. And for instance, and this is the whole power and the concept of this idea of load balancer. Let's create here a var second balancer equals load balancer dot get load balancer. And then we can actually just copy this over and then what we can expose on the load balancer is a method public int get request count. And here we'll just return request count. But of course, what we also need to do is here, we will also need request count plus equals 1. So that should do it. So right now, let's run this once again. And in this case, it would be the second balancer that we use. And then at the end, console.writeLine. Also, we'll use string interpolation here. Total requests sent. And we'll get here, for instance, we go for the balancer. So the first one, dot get request count. This would be the same method. And to make sure that we will get exactly the same value, as this is a singleton class, if this wouldn't be a singleton class, we would have here different values. But I would assume here we get 30 on both of those. So let's try to run this. And okay, we have sent a lot of, it's actually 38. Yeah, probably I did count wrongly. But we can see here that basically no matter what instance or what variable did we use, as this was a singleton, the count is always the same. And it's also the reason why we can keep track about what we are sending where. And of course, here in send request, if this would be software defined load balancer, let's call it that way. Of course, we could implement here different ways of sending requests, like round robin, like based on the server load, based on the server health, and things like that. But I guess this is this fits our purpose to define or to see exactly or to look into this concept of having a singleton design pattern. And before we wrap up, I just want to say a few more things. This concept of having a singleton instance is actually very easy at the base, and that was also the scope for this video, at least from my point of view. But of course, things could get a little bit more complicated because what we did here is actually not thread safe. So if we would work in a multi-threaded environment, basically what we could have the risk here that we could get actually 2 instances or even more instances of load balancer, because we would have to lock actually everything when we do this check if this instance is null. And in that case, we would actually make sure that we have a single instance, even if we would be in a multi-threaded environment. I just want to say that I'm aware about these complexities. We could also think about things like how we want to load the instance, if we want to eager load it or not. There might be different type of strategies there. But from my point of view, this is a more complex discussion, and it could be that we will cover it in a further video. But right now, I just wanted us to get started with this entire concept of implementing a singleton class, and to understand exactly the scenario when this would be a good fit. And also this very important concept and very basic and easy concept. In order to implement this idea of a singleton class, we just need a static field that keeps the instance. And then we have a private constructor, and we then expose a method to get an instance of that load balancer in this case. And what we do is that when this method gets called, we check if instance is null or not. If it is null, we just create a new one. If it is not null, then we will simply return it. And this will guarantee us that we will always return the same instance if we have one. So this being said, I guess that's mostly it for this whole idea of implementing a singleton class. As said, at its very core, it is not really complicated. It's actually very, very easy to grasp. And I guess that it's a good way to start going with this entire concept of design patterns. If you think that this video was useful for you, please don't be shy and drop a comment or hit the thumbs up or even subscribe, of course. And also don't be shy and feel free to share it with other colleagues or peers or friends that you think might be or that you think might benefit from this type of content. That would be really highly appreciated from my side, and I would be totally grateful. This being said, once again, thank you very much for watching, and until the next time, I wish you the very best.